Good Monday morning, neighbors. This one's going to be about impedance. I got another topic, but that one I'm still pondering. Impedance begins with a capital I. It's a resistance to change. Maybe that describes it. This is a concept, this concept of impedance. When you go apply the concept of impedance, you're not even aware of it. 8 out of 9 times. It's resistance to change, resistance to movement, resistance to flow. From that concept, from that idea comes river equations, how the water flows in a river, if it's turbulent or if it's calm, if there's rocks in the river or there's not, and the eddy currents the rocks create that affect the downstream rocks, or the avalanche or floods that affect the downstream rocks. So this impedance is a very interesting concept to apply. And it's very unique except for the word impedance. Impedance speaks to energy movement and what can affect that energy movement. First, I learned of impedance equations, impedance formulas, other than, just you notice in nature that a busy stream pushes rocks around or such. So in electronics, impedance equations apply to everything above a DC voltage. The fact that the power has a sine wave, the electrical current has a sine wave, changes the rules of its actions with the wires, with materials around it. So impedance equations. Now, most people in doing electronics, some will speak to it. But the details are fascinating. So electrical impedance equations. This is a realm of high-frequency electrical engineering, microwaves, radio frequencies. It's the subtle little things that maybe you're aware of, like what type of wire brings your cable into your house. There still are a number of standards out there depending on the frequency of transmission. Not what's on it, the frequency of the carrier changes the rules for that one wire coming into your house. You're probably not aware of that. You're probably not aware of the formulas that drive what we know about those wires and the right frequencies to be able to run into them. So in electronics, what happens is everything has a frequency function in the equations, because frequency affects the resistance of the system. Now, oddly, this electrical impedance, electrical waves, electrical energy, again, these equations change, but they're applied in wave theory, in liquid theory. Even in rocks and the motion of rocks, these theories apply, but the equations are different denominators, different numerators. Talking rocks instead of electrons, and rocks don't move like electrons. So you end up with a formula that's X of L let's see, X sub T equals X sub L plus X sub C, instead of a resistance formula where you add the resistance or you take the inverse of the resistance. If it's a parallel circuit, this is simple. You just take this for granted, right? So this impedance idea, the resistance to a change in flow. Impedance actually measures the change in current produced by the frequency and its interactions with the materials in the wire. It gets very strange because you're no longer talking about the flow of electrons through a wire at higher frequencies. They travel on the surface of the wire. At higher frequencies above that, you get into waveguides and wave theory for radar systems, for broadcast antennas, for receivers. I still listen to FM radio. And as you walk around town, you fall into wells of no reception because of the hills we have here. It's wave theory. It has to do with the resistance to the flow of ideas, impedance. The folks that know these equations, that would use these equations, don't come out and play. They can't do this. It's hard to speak to. It requires that you know Ohm's law, which is incomplete when you add a frequency. So this idea, this notion of a frequency and the importance of it is pretty big. But in that conversation, people can take it to the next level and take out their crystals and try to use this to show the crystals do something. They do. They make you feel good, and that's okay. So this frequency component has been left out of the conversation. This frequency component that was a staple of over a year's worth of school, looking at those equations and applying them to the reality of our military communications and radar systems decades ago. And all those ideas got lost. They didn't get passed on to the next generation or encouraged for the next. They went away because these wave theories, this electrons, this impedance, these flow things are a part of life too. Impedance. Interesting concept to apply. Fits in so many domains of the sciences: electrical, mechanical, physics. The idea of impedance applies to the particles we speak to in measuring radiation and radioactive particles. The frequency of those particles changes the effects they have on the surroundings and how quickly they can pass through it. So it's not a matter of 6 inches and stop. It's a matter of attenuation through space, attenuation through the environment. Gamma rays have a tendency to go through you. It takes a good bit to get those energies, those particles absorbed somewhere. That is the fact of attenuation and how it works. Throw your rock in the pond and make the ripple. Amazing. Watch it go around a rock. That signal's changed just a little bit. That's attenuation. It's not resistance. It is resistance. Only the equations are more complicated. So there's a simple 9 minutes talking around a concept of impedance. You could use that term in politics. You could use that term in social gatherings, in social ideas. There's good words out there. Thank you.